In section 2.5, we'll review inequalities, how to graph them, how to solve them, and to state our solution in interval notation. Part A, the first inequality is x is less than 3. And to graph this, I need to draw my number line. We always have to include a 0 in the middle. And we'll count 1, 2, 3. We're going to put an open circle at the 3 because x less than 3 does not include the 3. We need an open circle for the 3 because the solution does not include 3. And since we want to look at values of x that are less than 3, I'm going to draw an arrow and we're going to shade that pointing to the left. All these values are less than 3, but not including 3. For the interval notation, I will start off with a parentheses, a negative infinity, comma, 3, and another parentheses. Why do I use this? Well, it goes forever to the left towards negative infinity, and if we have an infinity symbol here, we always use a parentheses. The other end, it stops at 3. That's why we have a 3 here. And since this is an open circle, we always use a parentheses. Let's look at part B, a different scenario. In part B, this is pronounced x is greater than 3. X is greater than 3. Let's draw our number line. We need to start with a 0 in the center, and then we'll count to 3. And again, we're going to put an open circle because we're looking at the values of x that are greater than 3 but not including 3. So we'll draw an open circle to 3. And then we need to shade everything to the right of 3 because those are the values greater than 3. I'll shade everything to the right of the 3. It goes forever towards the right. It goes towards positive infinity. For my interval notation, since we're starting with an open circle, I'll use a parentheses, then a 3, comma, infinity, and then we'll close it off with another parentheses. We always use a parentheses for an infinity symbol, and on the other side, since it's an open circle, we have to use parentheses. And if you ever get confused, look at the number line versus our interval notation. It's in the same orientation. Negative infinities on the left, 3's on the right. Negative infinities on the left, 3's on the right. 3 is on the left, 3's on the left. Infinities on the right, infinities on the right. So that is how you can remember. It's in the same order as the picture on the graph. Part C, x is greater than or equal to 3. So in this case, we're going to draw the number line again. We'll start with the 0, and then we'll count our way to 3. This has to be a closed circle because 3 is a possible solution. It includes 3. X is greater than or equal to 3. So it's a closed circle in this case, and we're going to shade to the right. I need to shade to the right. These are all the values that are larger than 3. And this graph heads towards positive infinity. The interval notation is a square bracket first because it's a closed circle. All closed circles have square brackets. 3. And then it heads towards infinity. So we'll put the infinity symbol and always a parentheses for an infinity symbol. So this is the interval notation for x is greater than or equal to 3. For part D, this is pronounced x is less than or equal 2, 3. We'll start with a similar graph. 1, 2, 3. And this is going to be a closed circle again because it includes 3. It says x is less than or equal to 3. So shade it in, draw a closed circle for the 3. And we're going to darken the left side because the values of x less than 3 are on the left. And so I can write my interval notation now. It heads towards the left, towards negative infinity. It stops at the right here, and it's a closed circle. Closed circles are always with a square bracket. Open circles are always with a parentheses, and infinities always have parentheses. So you need to remember those different scenarios for this section. In question 1, we want to solve the inequality, graph it, and state the interval notation. The tip here is to keep the x on the left. If you keep the x on the left, we can reference our different scenarios we had earlier. If x is on the left, the arrow points to the left if it's a less than symbol. If it points to the right, then this points to the right. So if we keep the x symbol on the left, we can use the direction of the inequality to tell us where to shade. This points to the right. You can see that this arrow points to the right. Since x is on the left and the inequality is less, we can tell that this arrow points to the left. So that's a tip. If the x is on the left, we can use the direction of the inequality to tell us where to shade on the graph. So that's what I'm going to do for all of these problems. Keep the x on the left, and we could use the direction of the inequality to graph. We'll start by subtracting 3 to both sides of the inequality, and so x is less than 8. And now I can graph this on the number line. I'll start with the 0 in the middle. The 8 has got to be on the right. We'll have an open circle there because it's less than 8. And since we're looking for values that are less than 8, we'll shade to the left here. And now I'll state my interval notation. I like to write my interval notation directly under the picture. Since I know my endpoints, it goes to the left towards negative infinity. It goes to the right at 8. And there's a parenthesis because this is an open circle. That's my interval notation, and that's my graph. Question 2. We're going to keep the x on the left again. I need to get rid of that negative 6, so let's divide both sides by negative 6. But you have to remember, if you divide or multiply by a negative, you have to switch the direction of the sign. We have to remember to switch the direction of the sign if we divide or multiply by a negative. If you divide or multiply by a negative, you gotta switch the sign, switch the direction of the sign. It's very important. You have to switch the direction of the sign if you're dividing or multiplying by a negative for an inequality. And so we have 42 divided by negative 6 is negative 7. And again, notice that we switched the sign because we divided by a negative. Now I can start my graph. We have a 0 in the middle, a negative 7 on the left. We have to actually shade towards the left because we are looking at all the values that are less than negative 7. And what's my interval notation? My interval notation is negative infinity, comma, negative 7. with a parentheses. This is an open circle. We always use a parentheses. And since it heads towards negative infinity, we have a parentheses on that side as well. Question 3, I want to keep that x on the left, so I'm going to actually move it to the left. I will subtract 4x to both sides, and this gives me negative 4x minus 15 is less than negative 11. I can now add 15 to both sides. Now this becomes negative 4x is less than 4. And again, if I'm going to divide both sides by a negative, you gotta switch the direction of the sign. Since we divided by a negative, we gotta switch the direction of the sign. So we're gonna switch it facing towards the right this time. The point is towards the right. 4 divided by negative 4 is negative 1. And so we can graph our interval. We have a negative 1 here on the left. It's an open circle, and we're going to have to shade towards the right. Let's shade this towards the right. And I'm going to draw my interval notation. On the left side, it goes towards negative 1. It stops there. Don't forget a parenthesis since it's an open circle. It goes forever to the right, and we always put a parenthesis for an infinity symbol. And that's our interval notation. Question 4. I'll start by moving that x to the left side, just so we can use that direction of the inequality to help us graph. 5x minus 2x is 3x, plus 13 is now greater than negative 11. Let's subtract 13 to both sides. 3x is now greater than negative 24, and I can divide now both sides by 3. We'll divide both sides by 3. X is greater than negative 24 divided by 3 is negative 8. Notice we do not need to change the direction of the sign because we divided by a positive 3. It does not affect our inequality. Only if we divide by a negative or multiply by a negative. We'll start by graphing the negative 8. Again, an open circle because it's a greater than symbol. Let's shade towards the right because we want the values of x that are greater than negative 8. And I can write down my answer now in interval notation. A parentheses negative 8, comma, infinity. It's really nice to put my interval notation directly underneath my graph because it's the same orientation, negative 8 on the left and infinity on the right. Question 5, we have 5 times the quantity x plus 3 plus 2 is greater than 3 times the quantity x plus 4 minus 6. Same scenario, we have to get rid of those parentheses, and that means we need to do some distribution. 5 times x is 5x. 5 times 3 is 15. And we're going to treat this just like any other inequality. 3 times x is 3x. 3 times 4 is 12. And so we'll collect like terms first. I can add 15 and 2. So that's 5x plus 17 is greater than 3x is left alone, but we can add the 12 and the negative 6 together, which gives us positive 6. Let's subtract 3x to both sides now. And we can also save time by subtracting 17 to both sides, and that will simplify our inequality faster. 2x is greater than 6 minus 17 is negative 11. We could divide both sides by 2. So x is greater than negative 11 over 2. We can graph the 0 first. Where is negative 11 over 2? Well, you could write this as a decimal if you want, but I know that negative 11 over 2 is to the left of the 0, and since this is just a sketch, we don't really need to be precise. I'll just mark it down here as negative 11 over 2. It's an open circle, and we're going to shade to the right. Shade it towards the right because we want values that are greater than negative 11 over 2. The interval notation is a parentheses, negative 11 over 2, comma. It goes to the right towards infinity, so we'll put the infinity symbol. That's our graph. That's our interval notation. And this is our solution in inequality form. So these three solutions, they mean the same thing, it's just in a different form. For question 6, this is known as a compound inequality because we have two inequalities separated by the word or. So this is a compound inequality. It's exactly the same thing. We'll just solve each inequality separately. Again, keeping the x on the left. Here we have 2x is less than or equal to 4. We could divide both sides by 2 to get x is less than or equal to 2. That's one side of the inequality. For the other side, we can add the 7 to both sides. 2x is greater than or equal to 10. Divide both sides by 2. X is greater than or equal to 5. So here is our compound inequality. X is less than or equal to 2, or x is greater than or equal to 5. To graph this, we just have to graph two inequalities on the same picture. I'll always start with a 0. We need a 2, and it's a closed circle. And we need a shade to the left for that graph. We'll have a 5 here on the right. It's also a closed circle. Because of that equal symbol, it's greater than or equal to 5, it's included. And we have to shade towards the right, since all these values are greater than 5. For a compound inequality, graph the two inequalities on the same picture, or the same chart, and now we can state our interval notation. Here's my interval notation. It goes towards negative infinity. It stops at 2. It's a square bracket because it's a closed circle. We have another 5 here. It's a square bracket because it's a closed circle. We're going to shade towards the right, so that means it goes forever towards infinity. We'll have a parenthesis for the infinity. Now you can't just write these two separate inequalities. We have to join them together with the union symbol. We have this union symbol, and it's just another word or symbol for the word or. So when you use the union symbol, it means or. So our solution is negative infinity, comma 2, square bracket, union, square bracket 5, comma infinity, with a parenthesis at the end. So always use that union symbol once we have two inequalities separated by the word or. Question 7, again we have another compound inequality. I'll start by subtracting 17 to both sides here for the first inequality. Negative 2x is less than negative 12. We can divide both sides by negative 2. And of course, since we divided by negative, you have to switch the direction of the inequality. And negative 12 over negative 2 is positive 6. We'll look at the other side. Subtract 10 to both sides. Negative x is greater than negative 3. And I have to solve for x, so let's divide both sides by negative 1 to get that x by itself. And what happens when you divide by negative? You gotta switch the direction of the sign, so we'll switch it the other way. Negative 3 divided by negative 1 is a positive 3. Don't forget that or between them, because we have x is greater than 6 or x is less than 3. we have to use an open circle for the 3. And since x is less than 3, we're going to shade towards the left. And x is also greater than 6, we'll shade toward the right. This is open circles for both, because one is strictly less than 3, and the other one's strictly greater than 6. What's our interval notation? Negative infinity, comma 3, parentheses, and don't forget that union. We're going to join them together with a union. Another parentheses, 6, comma infinity. And if you look at the picture, look at our interval notation, it's in the same position. The 6 is on top of the 6, the 3 is on top of the 3, the infinity is on top of the infinity, and so we know that we wrote the correct interval notation. Question 8 is also a compound inequality, but there is no or in this compound inequality. There's just two inequalities mashed together. This is the only case where we want the x in the middle. I want to have that x in the middle if you see a compound inequality without the word or between. So this is a compound inequality without or. I call these traps because our solution is going to be trapped between two values. So let's trap the x in the middle. I'll start by adding 6. And when you add 6, you have to add it to both sides. But wait, there's actually 3 sides. So we have to add 6 to 3 sides of the inequality. The middle, the left, and the right. So it's very important. When x is in the middle here, this is a trap. We have to add to all 3 sides of this equation. Negative 21 plus 6, that is negative 15, less than or equal to 3x. This cancels out. That's less than or equal to 30. And now I could divide all 3 sides by 3. So you got to remember there's 3 sides to this inequality. So we have to divide all 3 sides by 3. This simplifies to negative 5 is less than or equal to x. And that's less than or equal to 10. Now let's graph this inequality. We need a negative 5. We need a 10. And since this is a closed circle, obviously it's got to be a closed circle for the 5. It's got to be a closed circle for the 10. But remember, this is negative 5 is less than or equal to x, and x is less than or equal to 10. So this is an AND inequality. That's how we pronounce it. Negative 5 is less than or equal to x, and x is less than or equal to 10. So we're going to actually shade in between. So a good way to remember is traps are shaded in between because the x is trapped between. And so this is my graph. We don't have an infinity symbol here for our interval notation. It's to the left negative 5, comma 10, to the right, and they're both square brackets because it just stops at negative 5 on the left and it stops at 10 on the right. So for traps, we don't have any infinity symbols.